Welcome to deep space. Emirates Mars Mission Infrared Spectrometer provides HOPE Orbiter's first temperature map of Mars. Press release, source, ASU posted March 10, 2021 11:23 p.m. 0 comments. The Emirates Mars Infrared Spectrometer, EMIRS, measures the thermal infrared energy emitted from the surface of Mars, top row, and its interaction with the Martian atmosphere, bottom row. Image credit, Emirates Mars Mission, EMIRS. The Emirates Mars mission, the first interplanetary exploration undertaken by an Arab nation, reached Mars orbit on Feb. 9, 2021. Now, some of the first images from the spacecraft's instruments are available, including planet-wide infrared images from the ASU-designed Emirates Mars Infrared Spectrometer, EMIRS. EMIRS was a joint development effort by teams from ASU's School of Earth and Space Exploration, Northern Arizona University's Department of Astronomy and Planetary Science, and the Mohammed bin Rashid Space Center, supported by teams from University of Colorado, Boulder's Laboratory for Atmospheric and Space Physics. Our work together with the teams at ASU and now on EMIRS has brought together some of the world's most respected experts in planetary atmospheric science together with younger learners who have benefited immensely from the development of the instrument and its scientific goals and resulting data sets, said Omran Sharaf, project director of the Emirates Mars mission. EMIRS provides a unique view of the lower and middle atmosphere of the planet, measuring the distribution of dust particles and ice clouds while tracking the movement of water vapor and heat through the atmosphere. In this initial image from the instrument, EMIRS provides results of measurements of thermal infrared energy emitted from the surface, top row, and from the atmosphere, bottom row. In the right column, EMIRS measurement locations were mapped to the planet, colorized by temperature, and overlain on a Mars orbiter laser altimeter shaded relief map. In the left column, data between measurements were interpolated, colorized by temperature, and overlain on a Mars orbiter laser altimeter shaded relief map to form a continuous image. This is the first global snapshot of the atmosphere that we have seen since the 1970s Viking mission, said EMIRS development lead Philip Christensen, who is an ASU Regents professor and planetary scientist. Weather is a global process, so having these global views gives us a powerful new tool for studying the dynamics of the Martian atmosphere and how it changes over time. Quote, the purple, green, blue hues show that the measurements were taken of the Martian night side, although dawn on the planet can be seen on the right-hand side of the surface temperature image, as depicted by the red hues. Features such as Arabia Terra, which has cold nighttime temperatures, can be observed in the upper left portion of the surface temperature data, depicted by the blue and purple hues. EMIRS is going to acquire about 60 more images like this per week once we transition into the primary science phase of the Emirates Mars mission, said EMIRS instrument scientist Christopher Edwards, who is an assistant professor and planetary scientist at NOW. We'll use these images and sophisticated computer programs to build up a complete global, daily understanding of the Martian atmospheric components, like dust, water, ice, water vapor, and atmospheric temperature. Quote, the Emirates Mars mission is being carried out by the Mohammed bin Rashid Space Center in the United Arab Emirates in collaboration with a number of research institutions including Arizona State University, Northern Arizona University and the University of Colorado Boulder. HOPE will spend 1 Martian year, about 2 Earth years, orbiting the red planet gathering crucial science data. The scientific goal of the mission is to give us an unprecedented global view of the Martian atmosphere, said Hessa al-Matrushi, science lead for the Emirates Mars mission. Such a perspective is necessary to understand the connections within and between the upper and lower atmospheres and how those connections help to drive atmospheric escape. We believe this escape has helped to shape Mars' evolution from a warm, episodically wet world in the ancient past to the cold, dry planet we see today. Quote, unique to HOPE is its orbit, which enables near-complete daily and geographic coverage, providing a weather satellite-style view of all layers of the Martian atmosphere from the surface on up to space. This mission is giving scientists greater insight into how our own planet may have evolved, as well as enabling greatly improved weather forecasting to help support future human missions to Mars. Importantly, HOPE addresses several key goals of the Mars Exploration Program Analysis Group, representing the consensus of the international Mars community, in regard to both science and human exploration. In addition to EMIRS, the orbiter includes a multi-band camera called the Emirates Exploration Imager, EXI, and a far ultraviolet imaging spectrograph called the Emirates Mars Ultraviolet Spectrometer, EMUS. The EXI camera is capable of taking high-resolution images and will measure properties of water, ice, dust, aerosols and ozone in Mars' atmosphere. The e-Muse spectrometer will measure global characteristics and variability in the thermosphere and hydrogen and oxygen coronae. Both were developed at the Laboratory for Atmospheric and Space Physics at University of Colorado, Boulder. The spacecraft, which is about the size of a small car, was constructed at Laboratory for Atmospheric and Space Physics by a joint team led by Project Director Omran Sharaf and Deputy Program Manager Sarah Al-Amiri from Mohammed bin Rashid Space Center. Al-Amiri currently serves as chair of the UAE Space Agency. The overall team working on the mission is comprised of some 200 staff from the Mohammed bin Rashid Space Center, 150 from the Laboratory for Atmospheric and Space Physics and 100 from other partners, as well as an international science team. The mission's name, Hope, was chosen to send a message of optimism to millions of young Arabs, according to Sheikh Mohammed bin Rashid Al Maktoum, the ruler of the Emirate of Dubai for whom Mohammed bin Rashid Space Center is named. The resulting mission data aims to make major advances in our understanding of the Martian climate system and will be shared freely online with more than 200 institutions worldwide. Thanks for watching.